OpenAI just did something nobody predicted. The company that's been buying Nvidia GPUs by the thousands announced it's made its own custom chip, and they're calling it a game changer. Here's the shocking part. This isn't just about having a cool piece of hardware. Custom chips are how you break free from relying on a single supplier. Nvidia's AI GPUs cost tens of thousands of dollars each, and OpenAI's been spending hundreds of millions on them every year to power ChatGPT and their other models. Now, with this new chip built alongside Broadcom, they're poised to drastically cut those costs, potentially by 30 to 40% depending on the workload. Think of it like this. If you're running a massive company and you're buying all your tools from one vendor, you're trapped. You pay whatever they charge, you wait for their next release, and you hope they don't cut you off. But if you design your own tools optimized exactly for how your company works, you own your destiny. That's what's happening here. OpenAI's chip isn't just about saving money on hardware. It's about reducing dependence on Nvidia, improving training speed for their models, and potentially offering cheaper AI services to everyone else. And here's where it gets interesting. Nvidia didn't become the AI king by accident. About a decade ago, their graphics processing units, GPUs, turned out to be perfectly suited for training AI models. They are fast, they are powerful, and they work brilliantly for the kind of math that AI systems need to do. So every major AI company, Google, Meta, Microsoft, Amazon, bought thousands of Nvidia GPUs to build their models. But here's the thing, Nvidia's a chip company. They make their money selling these GPUs. And because they're the only game in town for AI, they can charge basically whatever they want. A single Nvidia H100 GPU costs between $30,000 and $40,000. And if you're training a world-class AI model, you need thousands of them. For context, OpenAI reportedly spent between $1 billion to $5 billion on Nvidia hardware in the last couple of years alone. That's not a typo, that's an actual billion with a B. Other companies like Google and Meta have spent even more. So companies started asking, what if we designed our own chips specifically for AI? What if we optimized them just for our workload instead of using a general-purpose solution? Google actually did this first with their tensor processing units, TPU, back in 2016. But that's exactly why companies started asking a different question. So how does OpenAI's chip actually work? And what makes it different from just buying Nvidia GPUs? The answer comes down to specificity. OpenAI trained ChatGPT using a technique called transformer architecture, a specific way of processing data that's become standard across the AI industry. Transformers use something called attention mechanisms, basically parts of the neural network that focus on the most relevant information at each step. OpenAI's custom chip is designed specifically to run attention mechanisms efficiently. Instead of being a general-purpose processor, this chip is laser-focused on the exact math that ChatGPT does. Broadcom's role is manufacturing. OpenAI did the design work. They know their models inside and out, but actually making a physical chip requires serious semiconductor engineering and factory expertise. Broadcom has both. They understand how to optimize silicon, arrange billions of transistors on a single chip, and make sure data flows fast. Think of it this way. If OpenAI is the architect, Broadcom is the construction company. OpenAI says we need a chip that does X and Y incredibly fast, and Broadcom figures out how to build it at scale. The result is a processor that's cheaper to make than an equivalent Nvidia GPU and more efficient at the specific task OpenAI cares about. Efficiency means using less power, producing less heat, and needing less cooling infrastructure. For a company running massive data centers, that adds up fast. Let's talk concrete numbers. OpenAI claims their chip delivers the same performance as an Nvidia H100, but at roughly 60% of the cost. An H100 costs $35,000, so OpenAI's chip could be around $20,000. That's $15,000 saved per unit. Multiply by thousands of chips, and you're saving $50 to $100 million on a single training run. But it's not just about price, there's speed too. Because the chip is optimized for transformer models, it runs training and inference faster than a general-purpose GPU. Benchmarks suggest 30 to 50% speed improvements on certain workloads, meaning OpenAI can train faster, iterate quicker, and deploy new versions on shorter timelines. There's also power consumption. An Nvidia H100 consumes about 700 watts. You need serious cooling around that. OpenAI's chip, being more efficient, uses less power. A single data center of thousands of chips could save millions of dollars per year just in electricity. In regions where data centers pay premium power rates, that's significant. And here's something people overlook: cost stability. Nvidia controls GPU pricing and can raise prices whenever they want. But if OpenAI owns their chip design and has a manufacturing agreement with Broadcom, they control hardware costs long-term. No surprise price increases. That's a massive advantage. So how does OpenAI's chip stack up against the competition? First, there's Nvidia. The H100 is still the gold standard. It's general purpose. It works with all kinds of AI frameworks and models, and it's been thoroughly tested in production. But it's also expensive and not optimized for any specific use case. OpenAI's chip is cheaper and faster for their specific models, but it's not as flexible. It's purpose-built. Then there's Google's Tensor Processing Unit, the TPU. Google built their own AI chip years ago and has been refining it ever since. The TPU is actually more specialized than OpenAI's chip. It's even more narrowly focused on Google's specific workloads, but Google never commercialized it. You can't buy a TPU on the open market. Google keeps them for internal use. So OpenAI's move is interesting because they might eventually sell access to their chip to other companies. At least that's the possibility. There's also Intel, which has been trying to break into the AI accelerator market with their Gaudi chips. And there's AMD with their MI series, but neither of those has caught on at scale yet. They're not bad chips, but they don't have the software ecosystem or the proven performance that Nvidia has. OpenAI's chip is different because OpenAI is proving you can build something that works better for certain jobs and costs way less. If they open source their design or license it to other companies, it could become a real alternative. This announcement has massive implications for the entire tech industry. First, there's the competitive angle. If OpenAI can build a cheaper, faster chip for their models, other companies will take notice. Google will accelerate their TPU strategy. Meta might design their own chip. They actually have the talent in-house. Microsoft might push back on Nvidia more aggressively. The point is, Nvidia just lost their iron grip on the AI hardware market. They're not going away. Their GPUs are still incredible, but they can't raise prices with impunity anymore. Custom chips are a credible alternative. Second, there's the geopolitical angle. Building your own chips means less dependence on the United States supply chain, which matters especially for companies operating internationally. It also means less risk of sanctions or supply disruptions affecting your AI capabilities. Any company serious about AI infrastructure is now asking, should we design our own? Third, there's the implications for AI startups and smaller companies. Nvidia's dominance created a huge barrier to entry. If you wanted to train a large model, you needed tons of money to buy Nvidia GPUs. But if OpenAI's chip becomes available, or if other companies follow suit, there might be alternative paths. Prices might come down across the board just from having real competition. Here's the kicker: commoditization. The moment custom chips become viable, specialized processors for AI become commodities, and commodities have razor-thin profit margins. So what does this mean for you if you're a developer or someone who uses AI? Several things. First, costs might come down. OpenAI will save money on their hardware costs, and some of those savings could get passed to customers through cheaper API prices. That's not guaranteed. OpenAI is a business and they want to profit, but it's more likely than if they had no alternatives to Nvidia. Second, there might be new options for where you run your AI workloads. Right now, if you want to train a large model, you either use a cloud service like AWS, or you build your own infrastructure with Nvidia GPUs. But if OpenAI licenses their chip, or if other companies do the same, there might be more options with different trade-offs. Maybe one provider has cheaper inference costs, another has faster training speeds, another specializes in specific types of models. Third, and this is important for building AI applications, competition breeds innovation. When Nvidia had a monopoly, they could innovate at their own pace. Now they have pressure. That means faster releases, better software support, lower prices, more features. That benefits everyone building on top of AI. And if you're in the startup world, this is encouraging news. The barrier to entry for AI infrastructure just got lower. You might be able to access cheaper compute, which means more companies can afford to experiment with training and deploying their own models. That democratizes AI in a real way. Let's step back and see the big picture. OpenAI's custom chip isn't just a technology story, it's a power change. For 15 years, Nvidia has had a near monopoly on AI hardware. That era is ending. We're entering a period where multiple companies have custom chips optimized for their specific needs, and that competition will reshape how AI infrastructure works. But here's what really matters. This is about control. OpenAI realized that depending entirely on Nvidia was risky. If Nvidia raises prices, cuts off supply, or changes their roadmap, OpenAI's entire operation is affected. By building their own chip, OpenAI takes control of their own destiny. And that's the lesson everyone else in the industry is learning right now. Watch for this pattern to repeat. Every major AI company with enough resources will either build their own chip or invest heavily in alternative suppliers. Google's doubling down on TPUs, Meta is designing their own, Microsoft is pushing hard on negotiations with Nvidia and looking at alternatives. Within 5 years, custom chips will probably account for 40 to 50% of AI training hardware. Nvidia won't disappear. They are too good and too entrenched, but the game is fundamentally changing. The AI gold rush that made Nvidia unstoppable is transitioning into a period of diversification and competition. That's better for everyone except Nvidia shareholders. Follow for daily AI news to stay ahead of the next big change in this space.